Alright. Please don't knock my files over. So this is neurons. There's no computer in here at all. It's 16 neurons to generate a walking gait. Orientation sensing. Literally coat hanger wire and a colossal amount of flux. It's not welded, it's all soldered together, and I built this, oh my goodness, this was over 25 years ago. I'm going to push these back a little bit because I don't want to deal with that disaster. So it's not very smart. It just kind of walks in a straight line, and it's got a few things that are out of adjustment. Just it's literally made of junk. So this piece here is the metal shield from that went around a flyback transformer in an old portable TV. This side would have mounted to the circuit board, and the high voltage cable would have come out there. The motors are from a surplus store. I don't think they're even around anymore. There's a place many years ago called BG Micro. They were really popular for a while with robotics hobbyists because they had gotten a huge surplus of these security camera pan and tilt mechanism. Okay, all right, cool. So these are the old BG Micro motor, as some hobby communities used to call them. It was a little gear motor, and it was just perfect for robots like this. All the boards are hand etched. This is the neuron board, so this is kind of the brain. There's a 4-core central pattern generator on this T part of the board. And then there are 4 branches of 3 additional neurons each. And with the central generator and the 3 neuron branches, those generate the gait patterns for each of the legs. All of those run down these wires. These are literal old buried phone cable wires. I had an uncle who was working for the phone company when they first installed the internet trunk lines between towns, back when they installed internet back in like 95, 96 in where I lived. And so this is actually all old copper phone wire. But yeah, all these wires here kind of bundle together through here and go to this filter board. This board locks out invalid outputs and only allows valid outputs to pass through. So even if this neuron circuit glitches out, it won't like short out any of the motor controllers. Actually, this thing likes to saturate sometimes, and for the longest time, the way to get it to not saturate was to just literally blow on it. Like, just a little bit of moisture was enough to change the analog aspect of it to make it work. I actually dunked this whole thing in an ultrasonic cleaner. I cleaned the circuit boards, and it's been behaving a lot better since, but it does sometimes still seize up. But yeah. It's technically a dumb gate. It only has one pattern sequence. Is that leg? Oh, because that's joints breaking. I will have to fix that sometime. I was wondering why that was hanging so far out. Anyway, like I said, it's literally made of junk and surplus parts. But this circuit down here, if you think of this as the brain, you could think of this almost like the brain stem. These wires come up here. Every point on here is actually socketed. So if I wanted to, I actually originally designed this. I never did make anything to take advantage of it, but I have actual control lines on here where I can rearrange part of the gate sequence. So I could, if I wanted to, add sensors to this that could make it do things like back up or turn. And it's just one of those things I never got around to because I just thought, well, I'll just do another one, you know. But it's also been like 25 years. It's one of those, I'll do it someday, and then like a decade and a half goes by, you know. But yeah, this is Spyder, which is a perfect name for a four-legged thing. It has 8 motors, so I'm cheating. My naming is very, very unoriginal. So this would be what would back in the day have been called a beam robot. There was a guy named Mark Tilden, used to work at Los Alamos. He came up with this idea of doing very simple robots that complete tasks in swarms.